Hi ladies and gentlemen, this is Mr. Green and this is the last recording I'll be making in geometry for for the different lessons that we're doing. This particular lesson is one of the last ones in the special geometry issues that we've been looking at. Don't forget, get all your corrections in, get your due dates in. We are at the end of the semester, so it is important that you make certain you get everything turned in. What we're looking at here is projective geometry. That is, if I have a slide and I project it on a screen, the geometry of that projection, okay, that shining of the light through an object, because I have a version of the object here and then I'll have a bigger version of the object on the screen. So there's two versions of the object there, right? Well, that's what we're going to be looking at. Now, an affine transformation is a transformation in which the angles are preserved. Okay? So in this particular situation, if you'll notice how the angles here at C and at E and at G are not preserved in the definition over here. Okay? Not being preserved, it's not an affine transformation. It is skewed a little bit to one side. Okay? That's how you would say this. Now, how would you prove that this is not an affine transformation? Well, you could look at the distances. If you look at the distance from A to E and the distance from C to G and actually get the true measured distances, not the distances that you see in the chart there, then you could say that those distances are not equal and therefore it is not an affine transformation. It didn't preserve that distance. Okay? So, looking at this, if it were an affine transformation, if I had an image here, I would have a point here. It's kind of like a reflection. You remember how we did those, where we were reflecting through a particular point? Okay? And so we would go draw a line from here through that point out to here, and it would preserve the angles and the sides would be parallel to where they were originally. Okay? What you're looking at here is uh, actually it is that type of a reflective transformation. Okay, and so what you're talking about in doing in this situation would be the rules that you would use for reflection to be able to do this. Okay, so here I've got an image here that is another image up here. And it says, why is this central projection not an affine transformation? Because this image and this one are not similar in nature. And remember, similarity is what we were looking at trying to accomplish here. Because if I achieve similarity, then it would be an affine transformation. But because this side is not in ratio to this side as the same ratio of this one to this one, and my angles are not the same between the two, it would not be a similar object and therefore would not be an affine transformation. Okay? Now, there are other theorems in this one that you need to be aware of. This Pappus theorem says that if I've got points A1, B1, C1, A2, B2, and C2 that are on lines, and I draw a line to connect A1 to B2, and from A2 to B1, that point I could call point X. Okay? And if I continued on and I connected B2 to C1, yeah, went off my iPad. Try again. Okay? So if I go from B2 to C1 and from B1 to C2, that could be point Z. And then one more set of lines that I could draw here. I could go from A1 to C2 and from A2 to C1. And if I call that point Y, interesting little phenomena occurred. All three of these points are going to be collinear. They're going to form a straight line, X, Y, and Z. Okay? Doing this in a class connect like this is difficult, but you can see here, connecting those points here. You got X, you got Y, you got Z. That would be a straight line that would be between X, Y, and Z. Okay? Another one that goes along with that is Degas's theory. And Degas's theory says that if I take the lines of an object that's been projected, okay, and I extend those lines out like that, and do the projected line as well. And of course, it goes off the screen. Of course, it goes off the screen. There. There's one where they hit. Okay? Now, if I do that for all three sides here, all three pairs of sides here, okay? I want you to see what's happening. I'm getting 3 points, aren't I? Okay? Those 3 points are also going to be considered to be collinear. That is what Degas's theorem's telling you, is that they would be collinear lines. Okay? Better drawing of it there. Okay? So those are the theorems that are in theory of geometry. And I appreciate you listening to me all this time. This has been the last last lesson that I'm giving, and I will look forward to seeing you in Class Connect. Make certain you get everything turned in before the end of the semester. Talk to you later.